Find a comfortable place to rest. Let your shoulders drop. Let the weight of the day settle out of your hands. There is nothing left for you to do tonight. Nothing you need to solve. Nowhere you need to be. For the next while, all you have to do is listen and let your mind drift upward, past the ceiling, past the rooftops, past the thin shell of warm air that wraps the world, out into the cold and the quiet and the dark, where a single red star is slowly, gently taking its time to die. If you have ever stood outside on a clear winter night and looked up, you have almost certainly seen it, even if you did not know its name. Find the 3 stars in a short, straight row, evenly spaced, tilted at a slight angle like a belt. That belt belongs to Orion, the hunter, one of the oldest patterns human beings have ever traced across the sky. People were looking at these same stars and telling stories about them long before there were cities, long before there was writing, long before anyone had any idea what a star actually was. And just above that belt, off to one side, there is a star that glows with a soft, unmistakable warmth. Not white, not blue, a deep, burnt orange, the color of an ember that has been sitting in the fire a long time. That star marks the hunter's shoulder. Its name is Betelgeuse. Tonight we are going to spend a long, slow time with that single point of light. We are going to drift around it, and through it, and back into its distant past. And we are going to come to understand why this one quiet star, out of all the thousands you can see with your naked eye, is the one that keeps a certain kind of scientist awake at night. Not because it is dangerous to you. It is not. You are completely safe lying here, wherever you are. The story of Betelgeuse is not a story of danger. It is a story of scale, and of time, and of the strange, humbling fact that something so enormous and so far away can still, somehow, surprise the people who have spent their whole lives staring at it. That is the thing that unsettles them, not the fear of harm, the fear of not knowing. And by the end of tonight, you may find that the not knowing is the most soothing part of all. So let your breathing slow. Let the orange light of that star fill the space behind your eyes. And let us begin, very gently, by simply asking what it is you are actually looking at. When you glance up at Betelgeuse, the light reaching your eye tonight did not leave that star tonight. It did not leave last year. It did not leave in your lifetime, or your grandparents' lifetime, or the lifetime of anyone you have ever met. The light entering your eye right now left Betelgeuse roughly 600 years ago, give or take. The star is so far away that astronomers still argue about exactly how far, but the best estimates place it somewhere between 500 and 700 light-years from where you are resting, with most of those estimates settling comfortably around 640 to 700. A light-year is the distance light travels in a single year, and light is the fastest thing there is, moving so quickly that it could circle the entire Earth more than 7 times in 1 second. And yet to cross the gulf between you and Betelgeuse, that same impossibly fast light needs centuries. The glow you see is old. It is a message sent from the Middle Ages, drifting across the emptiness all this time, only now arriving at the back of your eye. The star that sent it has long since moved on to whatever it is doing now, and we will not know what that is for another 600 years. Hold that thought softly, because we will return to it later, and it carries a quiet weight. Now the distance is staggering, but the distance is not the thing that makes Betelgeuse remarkable. What makes it remarkable is its size. We have to slow down here because the human mind is simply not built to hold numbers this large. and the only way to feel them is to build them up gently, one comparison at a time. Start with our own sun. The sun is so large that you could fit roughly 1 million Earths inside it. When you stand in a field on a summer afternoon and feel the heat of the sun on your face, you are feeling the warmth of an object so vast that our entire planet, all the oceans and mountains and cities, and every person who has ever lived, would be little more than a speck against it. That is the sun. That is our star. And by the standards of the universe, our sun is ordinary, average, a perfectly typical, middle-of-the-road star. Now take that sun, that million Earth furnace, and imagine it swelling. Imagine it growing until it is not just bigger, but unrecognizably, monstrously larger. Betelgeuse is a red supergiant, and it is roughly 700 times the diameter of our sun. Some measurements push that figure even higher, toward 1,000 times, but let us stay with 700, because 700 is already almost too much to feel. If you could somehow lift our sun out of the center of our solar system and set Betelgeuse down in its place, the surface of that red giant would not stop at the orbit of Mercury or Venus or even Earth. It would swallow them whole, all of them, without slowing down. It would engulf Mars. It would keep expanding outward, past the asteroid belt, until its glowing edge reached somewhere near the orbit of Jupiter. Everything we know, every world in the inner solar system, every place a human being has ever set foot or sent a spacecraft, all of it would be buried deep inside this single star, like pebbles dropped into the heart of a bonfire. Let that image rest in your mind for a moment. Not as a threat, just as a scale. A single star, so large that our entire neighborhood of planets would fit comfortably inside it, with room to spare. That is what you are looking at when you glance up at the hunter's shoulder. A faint orange dot, no bigger to your eye than any other star. That is in truth one of the largest single objects ever clearly seen by human beings. And here is something gentle and strange about a star that large. Because Betelgeuse is so enormous and relatively so close, it is one of the only stars in the entire sky, other than our own sun, whose surface we have actually been able to photograph. Think about that for a moment, in the soft way you think about things just before sleep. Every other star you can see is, no matter how powerful the telescope, just a point, a dot, a single pixel of light, too far and too small to show any detail at all. We can measure them, study their light, learn their chemistry, but we cannot see their faces. They remain points. Betelgeuse is different. Betelgeuse is so big that the great telescopes of Earth and the Hubble Space Telescope orbiting above us have managed to resolve it into an actual disk, a circle with features on it, a surface that changes over the years. We have seen its face, and its face is not smooth. The surface of Betelgeuse is not calm. It boils. Picture a pot of thick soup heating on a stove, the slow way the surface rolls and swells, great bubbles of hot material rising up from below, dumbing the surface, then cooling and sinking back down so that new hot material can rise in its place. That is what is happening on Betelgeuse, except the bubbles, the convection cells as astronomers call them, are almost beyond imagining. On our sun, these convecting cells are about the size of a country. On Betelgeuse, a single one of these rising bubbles of star stuff can be larger than the entire orbit of the Earth around our sun. Vast continents of glowing plasma, each one wider than the path our planet takes in a full year, rising slowly to the surface, glowing brighter as they arrive, then darkening and sinking back into the depths. The whole star shimmers and shifts because of this, brightening here, dimming there, breathing in a slow, irregular rhythm over months and years. When astronomers first managed to photograph its surface in the 1990s, they saw exactly this: a mottled, uneven, blotchy face. Bright spots and dark spots, a star with weather, a star that, when you finally get close enough to see it clearly, turns out to be restless and alive. There is a name on that star, and the name itself is old and worn smooth by time, the way a stone in a riverbed is worn smooth by the water passing over it. Betelgeuse. Say it slowly. The word came to us across many centuries and many languages, carried out of the astronomy of the medieval Arab world, where the great figure we call Orion was seen and named in ways of their own. The original phrase is usually traced back to something like the hand or the shoulder of the giant figure they saw in those stars, a figure they called Al-Jawza. Over the long centuries, as the name was copied from one language into another, written and rewritten by scribes who did not always know exactly what they were transcribing, the sound shifted and slid and settled into the form we use now. Betelgeuse. A word that is, in a sense, a small fossil of human history, the trace of countless people in countless places looking up at the same red star and reaching for a word to hold it. You are only the latest in a line of watchers that stretches back further than anyone can count. That thought has a gentle weight to it. Every single person who has ever looked up and wondered about that warm red light is, in some quiet way, keeping you company tonight. And just as the giant has a glowing red shoulder, he has, on the opposite corner of his great striding shape, a brilliant blue-white foot. That star is called Rigel, another name worn down from the Old Arabic, this one meaning simply the foot. Rigel sits diagonally across from Betelgeuse on the far side of the belt, and the two of them make one of the loveliest contrasts in the entire sky. Betelgeuse, warm and orange and soft, the color of a dying ember. Rigel, cool and white and sharp, the color of ice catching the moonlight. One an old red giant near the end of its life, the other a younger, hotter, blue-white star still burning fierce and clean. If you ever find yourself outside on a clear winter night, you can see the whole story laid out for you in a single glance. Find the 3 belt stars in their tidy row. Then look to one corner for the warm red light, and to the opposite corner for the cool blue one. And you are looking at 2 completely different chapters of a star's life, hanging side by side in the same constellation, separated by hundreds of light years and millions of years of difference, yet appearing to your eye to be neighbors. The hunter wears the beginning and the end of stellar life on his 2 shoulders and his 2 feet, and most people walk past it every winter without ever knowing. For most of the long history of people watching this star, it seemed utterly changeless, reliable, a fixed point you could trust. The ancient watchers, the sailors, the farmers marking the turn of the seasons, all of them saw the same steady red light year after year, and it must have seemed as permanent as anything could be. It was not until fairly recently, in the 1700s and 1800s, as astronomers began keeping truly careful records of exactly how bright each star appeared, that anyone realized Betelgeuse was not quite as steady as it looked. A great astronomer of that era, watching patiently and writing down his measurements, noticed in the 1830s that the red star's brightness was not holding perfectly constant. It was wavering, drifting up and down by small amounts over time. He was among the first to record, in careful ink, that Betelgeuse is a variable star, a star that changes, and once people knew to look, they could not unsee it. The slow yearly breathing, the gentle swelling and fading had been there all along, hiding in plain sight, waiting for someone patient enough to notice. There is something deeply human in that. The thing had been right there above everyone's heads for all of history, and it took the simple discipline of writing the numbers down, night after night, year after year, to reveal that the changeless star was quietly alive and moving the whole time. So much of what we know about the sky came not from a single dramatic discovery, but from someone, somewhere, patiently paying attention for a very long time. So that is the first thing to hold on to as you settle deeper into the dark. Betelgeuse is not a tidy little point of light. It is a colossal, slowly boiling sphere of glowing gas, hundreds of times wider than our sun, far enough away that its light is 6 centuries old by the time it reaches you, and yet near enough and large enough that we have actually seen the great hot bubbles moving across its surface. It is, in the most literal sense, a giant. And like all giants in the oldest stories, it is both magnificent and doomed. To understand why it is doomed, and why that word is the right word even though there is nothing sad about it, we have to go back to the beginning. We have to ask how a star like this comes to exist at all. So let your thoughts drift backward now, not just across the 600 light-years of space between you and Betelgeuse, but across time, back to the moment this star was born. A star begins with almost nothing. It begins with a cloud. Out in the spaces between the stars, in the great dark stretches that look completely empty to our eyes, there is in truth a thin haze of gas and dust. Mostly hydrogen, the simplest and oldest element in the universe, left over from the very first moments after everything began. This gas drifts, cold and quiet, for unimaginable lengths of time, and then, somewhere, something nudges it. The shock wave from a distant explosion, perhaps, or the slow gravitational pull of the gas upon itself, gathering, thickening, growing denser in the middle, and once a clump of this cloud becomes dense enough, gravity takes over completely. The cloud begins to fall inward toward its own center, pulling more and more material into an ever tighter, ever hotter ball. As the material crushes together, it heats up, the way the air in a bicycle pump grows warm when you compress it, only on a scale beyond anything you have ever felt. The center of the collapsing cloud grows hotter and hotter and denser, until at last, at the very core, the temperature crosses a threshold, and something extraordinary happens. The hydrogen atoms, squeezed together with unbelievable force, begin to fuse. 2 atoms become one, and in that fusion, a tiny amount of matter is converted into a tremendous amount of energy. The star switches on. A new sun is lit. This is how every star in the sky was born, including our own. But Betelgeuse was not born ordinary. The cloud that became Betelgeuse was enormous, far larger than the cloud that became our sun, and so the star that ignited at its center was a heavyweight from the very first moment. When Betelgeuse was young, it was not red. It was not a gentle ember at all. It was a brilliant, ferocious, blue-white star, blazing far hotter and far brighter than our sun, burning through its enormous reserves of fuel at a furious pace. And here we come to one of the great, quiet ironies of the universe, the kind worth turning over slowly in the dark. The bigger a star is, the brighter it burns, and the brighter it burns, the faster it dies. It feels backward, doesn't it? You might imagine that a star with vastly more fuel would simply last vastly longer. But it does not work that way. A massive star is so heavy that the crush of its own gravity is enormous, and to hold itself up against that crush, it must burn its fuel at an absolutely reckless rate, far faster than the simple amount of extra fuel can account for. A small, dim, modest star can sip its fuel slowly and shine steadily for tens of billions of years, longer than the universe has so far existed. Our own sun, average as it is, will live for roughly 10 billion years in total, and it is only about halfway through. But a giant like Betelgeuse lives fast. It pours out its energy in a desperate, dazzling rush. And so, despite having far more fuel than the sun, Betelgeuse will live only a tiny fraction as long. How long has it lived already? Betelgeuse is only about 10 million years old. Say that number softly and compare it to the sun. 10 million years against the sun's 10 billion. Betelgeuse is 1,000 times younger than our star, and yet it is already old, already near the end, already approaching its death, while the sun, 1,000 times its senior, is comfortably middle-aged, with billions of peaceful years still ahead. If our sun were a person in the calm middle of a long life, Betelgeuse would be a creature that was born, grew to a towering size, and aged into its final years, all within the space of a single human afternoon. It burned too brightly to last. The most luminous things rarely do. And so, having raced through the easy part of its life, the long stretch where it simply fused hydrogen into helium in its core, the way our sun does now, Betelgeuse ran into trouble. It ran low on hydrogen at its center. And when a star runs low on the fuel at its core, it does not simply switch off and fade away. It changes. It transforms. The core, no longer producing enough energy to push outward against gravity, begins to contract and heat up even further, while the outer layers of the star, responding to the shifting balance of forces, do the opposite. They billow outward. They swell. The star expands enormously, and as it expands, its surface spreads its heat over a vastly greater area, so the surface cools, and as it cools, its color shifts, from blue-white, down through white and yellow, and finally to the deep, glowing red we see today. The star didn't get cooler because it got weaker. It got cooler at the surface precisely because it grew so vast. This is what a red supergiant is. It is a massive star in its old age, bloated to titanic size, its surface gone red and cool, even as its core grows ever hotter and more frantic underneath. Betelgeuse was once a fierce blue jewel. Now it is a swollen red giant, beautiful in a different and gentler way, glowing softly on the hunter's shoulder, living out the final, restless chapter of a life that burned far too hot to be long. That is where we find it tonight. An old giant near the end, breathing slowly, its great convection cells rising and sinking, its surface shimmering, 600 light-years away, sending us the light of its long, slow twilight. And for most of human history, that is all anyone knew, or could know. Betelgeuse was simply the red star on the hunter's shoulder, a fixed and faithful point in the winter sky, returning every year as the seasons turned, as constant as anything in the heavens. But it turned out that Betelgeuse was not constant at all, and the moment that became impossible to ignore, the moment this quiet old star reached out across 600 years of darkness and genuinely frightened the people who study the sky, came not in some distant century, but recently, within living memory. It came in the winter of 2019, and it began, as so many unsettling things do, with something that should have been nothing at all. A simple, gradual, harmless dimming of the light. For more than a century and a half, astronomers had kept careful records of how bright Betelgeuse appeared in the sky. Going back to the 1800s, patient observers had noted, night after night, year after year, that the star's brightness rose and fell in a gentle, predictable rhythm. It was a variable star, one that breathes, swelling and shrinking very slightly over a cycle of a little more than a year, about 400 days, growing a touch brighter and then a touch dimmer in a slow heartbeat that had held steady for as long as anyone had been watching. Nobody worried about it. The rhythm was familiar. It was part of who Betelgeuse was. A breathing star, sighing softly over the months, never doing anything alarming, never breaking its pattern. And then, in October of 2019, it broke its pattern. It started quietly. The star began to fade, which in itself was nothing unusual, because Betelgeuse fades a little on its regular schedule. But this time, it did not stop at the usual point. It kept going. Through November, the dimming continued. Through December, it deepened. The astronomers watching their instruments began to look more closely, because the numbers were drifting past the edges of anything in their records. By January of 2020, Betelgeuse had dropped to a level it had never reached in all the long decades of careful observation. And still it kept falling. By the middle of February, the star had faded to roughly a third of its normal brightness. It had become the faintest it had been in nearly 200 years of recorded watching. Anyone who knew the winter sky could see it with their own eyes. No telescope needed. The familiar bright shoulder of Orion had gone dim. The hunter looked wrong. One of his shoulders had nearly faded out. Now, here is where you have to understand the thing that ran through the minds of the people who knew what they were looking at. The thing that made this more than a curiosity. Because they knew what Betelgeuse was. They knew it was a red supergiant near the end of its life. They knew that a star like this, when it finally reaches the very end, does not simply fade away into the dark. It explodes. A red supergiant of this size ends its life in one of the most violent events the universe is capable of producing. A supernova, an explosion so bright it can briefly outshine an entire galaxy of billions of stars. And one of the things that can happen in the final approach to that explosion, in the last stages before a massive star tears itself apart, is that its behavior becomes erratic. It can shudder. It can pulse strangely. It can perhaps dim. So when Betelgeuse, an old red supergiant that everyone knew would someday explode, suddenly began to fade in a way it had never done in all the time anyone had been watching, a quiet, electric question went around the community of people who watched the sky. Was this it? Was the star beginning to die? Here, now, in front of us, in real time. Were we, by sheer luck, alive at the exact moment in the long history of the universe when this particular giant chose to fall? Telescopes all over the world, and in orbit above the world, turned to point at the hunter's shoulder. It became one of the most watched objects in the entire sky. Astronomers cancelled other plans. Observing time on the great instruments was redirected. Everyone wanted to see what would happen next, because if Betelgeuse was about to go supernova, it would be the closest, brightest, most spectacular stellar explosion seen by human eyes in over 400 years, an event that would light up the daytime sky and that no living person had ever witnessed. And underneath the excitement, there was something more sober, because nobody actually knew what the warning signs of a supernova look like. This is one of the genuinely humbling truths at the heart of this whole story, and it is worth letting it settle in slowly. We have never watched a star in the final days before it explodes. We have seen plenty of supernovae, distant flashes in faraway galaxies, the aftermath, the explosion itself, and the fading glow that follows. But we have never had a nearby star, close enough to study in detail, that we were watching carefully in the hours and days leading up to the moment it blew apart. We have no checklist, no reliable list of symptoms, no way to look at a dimming star and say, with confidence, yes, this means the end is days away. Or no, this is nothing. We are, in a very real sense, reading a book whose final chapter we have never been allowed to see. And so, when Betelgeuse dimmed, the honest answer to the question on everyone's mind, is this the end, was simply, we do not know. We have never seen this before. We will have to watch and find out. That uncertainty is the thing. That is what genuinely unsettles scientists about Betelgeuse, and it is worth being clear about it, because the popular story is often that they are afraid of the explosion itself, afraid of some danger crossing the gulf of space to harm us. They are not. We will come to the question of safety in time, and the answer is deeply reassuring. What truly unsettles a thoughtful astronomer is something quieter and stranger. It is standing in front of a giant, a thing they have studied their entire careers, a thing they thought they understood, and watching it do something completely unexpected and realizing they cannot say what it means or what comes next. It is the experience of looking at the universe and being reminded, gently but firmly, that it does not owe us an explanation, and that our knowledge, for all its power, has edges. The great dimming, as it came to be called, was a face-to-face encounter with the edge of what we know, and that is a far more interesting kind of fear than the fear of harm. It is the fear of mystery, the good kind, the kind that, lying here in the dark, you can actually find restful, because it reminds you how much wonder is still out there, unsolved, waiting. So the telescopes watched, and slowly, over the weeks that followed that deep minimum in February of 2020, something happened that began to ease the tension. Betelgeuse stopped fading. It steadied, and then, gently, it began to recover. The light crept back up. Through the spring of that year, the star brightened, climbing back toward its normal glow, and by April, only a couple of months after it had reached its faintest point, Betelgeuse had very nearly returned to the brightness it had always had. The hunter's shoulder was whole again. Whatever had happened, it had not been the end. The star had not exploded. It had simply done something it had never been recorded doing before, and then it had recovered, leaving the astronomers with an enormous and fascinating question. If it was not the beginning of a supernova, then what on earth had just happened? What could make a star this size lose a third of its light and then get it all back within a matter of months? And solving that mystery turned out to reveal something far more beautiful than an explosion. Because the answer was not destruction. The answer was creation. Drift with me into it slowly. When the dimming first began, there were two main ideas about what might be causing it, and for a while it was not clear which was right, or whether it might be some combination of both. The first idea was about temperature. Remember those enormous convection cells, the country-sized and larger bubbles of hot plasma rising and sinking across the star's surface. Suppose a particularly large and cool region had risen to the surface, a great dark patch, cooler than its surroundings, spreading across a significant fraction of the face we can see. A cooler surface gives off less visible light, and so the star would appear to dim, not because anything was blocking it, but because part of its surface had genuinely cooled down. That was one possibility. The second idea was about dust. And to understand the dust, you have to know that Betelgeuse, like all red supergiants, is constantly losing material. It is so large, and its gravity at the surface is so gentle, spread across that vast, bloated sphere, that the star is perpetually shedding its outer layers into space, breathing out a slow, steady wind of its own substance. Betelgeuse loses mass at a rate something like 30 million times faster than our Sun does. It is gently evaporating, returning its own material to the darkness between the stars, and the material it sheds, the gas streaming away from its surface, can cool as it travels outward, and when certain elements in that gas cool down past a particular point, they condense. They solidify into tiny solid grains. They become, quite literally, dust, cosmic soot, and a cloud of such dust hanging in space between us and the star could block some of the light and make Betelgeuse appear to dim, the way a thin veil of smoke can dim the sun without the sun itself changing at all. When the great telescopes turned their full attention to the problem, and when astronomers managed to capture detailed images of the star's surface during the dimming, the picture that emerged was richer than either simple idea alone. It seems that both things happened, and that one led to the other in a single connected event. Here is the story that the evidence tells, and it is a remarkable one. Some months before the dimming, one of those vast convection cells on Betelgeuse's surface did something violent. It surged. A great upwelling of hot plasma rose from deep within the star and burst outward through the surface, flinging an enormous bubble of hot gas off the star entirely and out into the surrounding atmosphere. This was not a gentle breath. This was an outburst, a heave, a star throwing up a piece of itself. Astronomers gave it a name, a surface mass ejection. Our own sun does something faintly similar on a small scale, flinging out bursts of material called coronal mass ejections, the things that cause the northern lights when they wash over the Earth. But what Betelgeuse did dwarfed anything our sun has ever done by an almost unbelievable margin. The amount of material Betelgeuse blasted off its surface in that single event was something like 400 billion times greater than a typical eruption from our sun. The star, in effect, blew off a substantial piece of its own visible face and hurled it into space. And then the second part happened, the part that turns this from violence into something gentler. That enormous cloud of hot gas, racing away from the star, began to cool as it expanded into the colder space beyond. And as it cooled, just as a red supergiant's wind always does given the chance, the gas condensed. The vaporized elements within it, things like silicon, the same kind of material that makes up sand and glass, and the rocks beneath your feet, cooled and hardened into tiny solid grains. A vast cloud of fresh dust formed, right there in front of the star, exactly in our line of sight. And that newborn cloud of dust blocked the light from roughly a quarter of Betelgeuse's surface, as seen from Earth. The star itself hadn't died. It had not even truly diminished in any permanent way. It had simply sneezed in the most spectacular fashion imaginable, and the cloud from that sneeze had drifted across its face and shaded it from our view. As the cloud continued to expand and thin and disperse over the following months, it let the light through again, and the star returned to its full brightness. Now hold this next part softly, because it is, to my mind, the most quietly wonderful thing in the entire story of the Great Dimming. When astronomers realized what they had seen, they understood that they had just watched, in real time, with their own instruments, the birth of cosmic dust. They had witnessed a red supergiant flinging its own substance into space, and then watched that substance cool and harden into solid grains. And those grains, that very dust, are not waste. They are the seeds of everything. The dust that drifts away from dying giant stars like Betelgeuse, spreading slowly through the galaxy over millions of years, is the raw material from which new clouds gather. And from those clouds new stars are born, and around those new stars, planets. The silicon in that dust cloud, the same kind of material thrown off by Betelgeuse, is the same kind of material that billions of years ago, and gathered from countless dying stars before our own, formed the rocky body of the earth beneath you. We are, in the most literal and unsentimental sense, made from the dust of dead and dying stars. And during the Great Dimming, for the first time, human beings got to watch that dust actually being made. One astronomer described it as having directly witnessed the formation of stardust, the thing that frightened the world, the dimming that made people whisper that the star was dying, turned out to be the star scattering the very seeds of future worlds. The fear and the wonder were the same event, seen from two sides. So the Great Dimming was solved, more or less. A surface mass ejection, a cloud of newborn dust, a temporary veil, a recovery. The supernova fear faded along with the dust. But the story was not over. Because in studying Betelgeuse so intensely during and after the dimming, in pointing every available instrument at it, and watching it more closely than ever before, astronomers found themselves confronting an older, deeper mystery, one that had been sitting quietly in the data for decades, ignored, waiting. And the solution to that older mystery, when it finally came, just in the last couple of years, turned out to be one of the most charming and surprising discoveries in modern astronomy. To get to it, we have to look not at the 400-day breathing rhythm of the star, but at a second, slower, far stranger rhythm that no one had ever been able to explain. Let your mind settle into this slower rhythm now, the way you might settle into a slower breath as sleep draws nearer. Because alongside that gentle, year-long heartbeat, the rising and falling over about 400 days, astronomers had noticed, going back many decades, that Betelgeuse had a second cycle layered on top of the first, a much longer one. Over a span of roughly 2,170 days, which works out to a little under 6 years, the star's brightness would slowly swell and slowly fade, a long, ponderous tide beneath the quicker waves of the yearly breathing. Nobody knew why. The 400-day rhythm made sense. It was the star itself pulsing, expanding, and contracting, the natural breathing of a giant. But the 6-year rhythm had no obvious cause. It was too long, too regular, too separate from everything else. For decades, it simply sat there in the records, an unexplained slow heartbeat, a puzzle that most people set aside because there were always more pressing things to study. A star with a mystery in it, a rhythm with no known source. After the Great Dimming drew so much attention to Betelgeuse, a few astronomers turned back to that old, slow 6-year cycle and began to take it seriously again. And in the year 2024, 2 independent groups of researchers, working separately, arrived at the same startling idea. What if the 6-year rhythm was not coming from inside Betelgeuse at all? What if it was being caused by something outside the star? Something orbiting it? What if Betelgeuse, this lone red giant on the hunter's shoulder, was not alone? The idea was this. Suppose there is a second, much smaller star circling Betelgeuse, going around it once every 6 years or so. And suppose that as this companion moves along its orbit, it sweeps through the dusty material around the giant, clearing a path, pushing the dust aside, the way a small boat cuts a wake through scattered leaves on a pond. When the companion clears the dust, more of Betelgeuse's light reaches us, and the star looks brighter. As the companion moves on and the dust drifts back, the star dims again. A hidden partner, orbiting in the dark, brushing the dust aside once every 6 years, would explain the long, slow rhythm perfectly. It was an elegant idea. It was a beautiful idea. But it had one enormous problem. Nobody had ever actually seen this companion, and the reason nobody had seen it is the same reason it was so hard to find. Betelgeuse is monstrously, blindingly bright, hundreds of times the size of the sun and thousands of times more luminous, and any small companion star orbiting close to it would be utterly lost in that glare, like trying to spot a single candle held up directly in front of a lighthouse. The companion, if it existed, was hiding inside the light of the giant itself. People had looked before. The Hubble Space Telescope had looked. A great X-ray observatory had looked, and they had found nothing. The companion was either not there, or it was so well hidden that our best instruments could not pull it out of the glare. But the people who proposed it had a crucial advantage. If the dimming and brightening followed a 6-year orbit, then the geometry of that orbit could be calculated, which meant they could predict exactly when the hidden companion, if it existed, would swing out to its greatest distance from the giant, the moment when it would be as far from the blinding glare as it would ever get. The one brief window every 6 years when it might just be possible to catch a glimpse of it. And those calculations pointed to a particular window. Early December of 2024. For a few precious days around the 6th of December, the hidden companion, if it was real, would reach its maximum separation, lean out as far from Betelgeuse's glare as it ever leaned, before swinging back and vanishing behind the giant for another 2 years. It was a single, narrow chance. Miss it, and they would have to wait years for another. So a race began. Astronomers scrambled to secure time on the most powerful instruments they could reach, pointing them at the hunter's shoulder in that brief December window, hoping to catch, in the faint sliver of separation, the ghost of a star that might not even be there. And on the 9th of December, 2024, using a special instrument on a great telescope perched on a mountaintop in Hawaii, an instrument designed to see through the blur and the glare with extraordinary sharpness they looked. And there, just beside the overwhelming brightness of Betelgeuse, exactly where the calculation said it should be, separated from the giant by the tiniest of angles, they found a faint point of light. The companion was real. After decades of an unexplained rhythm, after a beautiful theory and a desperate window and a race against time, there it was. A second star, orbiting Betelgeuse, hiding in its glare, brushing the dust aside once every 6 years. They had found it, and being human, and being delighted, they gave it a nickname before it had a proper name. They called it Beetle Buddy. Now, finding the companion was only the beginning, because the moment they found it, a new question opened up. What exactly was this thing? What kind of star had been hiding inside the glare of the giant all this time? And here the story takes a turn that genuinely surprised the people studying it, the kind of surprise that is worth savoring as you lie here, because it is a reminder that the universe rarely hands us the answer we expect. The natural assumption, the thing most astronomers would have guessed, was that the companion would be a stellar corpse, a small, dense, burnt-out remnant, perhaps a white dwarf, the cooling ember left behind when a smaller star finishes its life, or even a neutron star, the impossibly dense core left over from some past explosion. The reasoning was sensible. Betelgeuse is old. It is near the end. It seemed likely that anything orbiting it would be old as well. An aged little corpse circling an aging giant. Two stars at the end of things keeping each other company in the dark. So in the autumn of 2025, a team of researchers went looking for confirmation. They secured precious emergency time on two of the most powerful instruments ever built, a great X-ray observatory and the Hubble Space Telescope, and they pointed them at Betelgeuse during another of those rare windows when the companion leaned out from behind the glare. They expected to find the telltale signature of a stellar corpse. A white dwarf or a neutron star is hot and dense, and objects like that tend to give off X-rays, a kind of high-energy light that the X-ray observatory was built precisely to detect. If the companion was a corpse, it should glow in X-rays. They looked, and they found no X-rays at all. The companion was silent, in exactly the way a corpse shouldn't be. What the evidence pointed to instead was something far gentler and far stranger. The companion does not appear to be a dead star at all. It appears to be a young one. A small star, roughly the mass of our own sun, perhaps even less, but crucially, a star that is not old and not dying. Stranger still, it seems to be a star that has barely begun. The best understanding right now is that Betelgeuse may be a pre-main sequence star, which is the term for a star so young that it has not yet truly switched on, not yet begun the steady fusion of hydrogen that defines a star's long adult life. It is, in a sense, a stellar infant, and this creates one of the most poignant pairings in the entire sky. Betelgeuse and its companion were born at the same time, from the same cloud, about 10 million years ago. They are exactly the same age. And yet, because Betelgeuse was born so much heavier, it has raced through its entire life, while its little sibling has barely gotten started. One of them is an ancient giant at the very end of existence, swollen and red and shedding its substance into space. The other, the same age to the year, is still a newborn that has not yet drawn its first true breath of starlight. The same age, opposite ends of everything, drifting around each other in the dark, 600 light-years away. This pairing also broke some of the rules astronomers thought they understood. When two stars form together as a pair, they usually come out with fairly similar masses, born of the same cloud in roughly balanced portions. But Betelgeuse weighs perhaps 16 or 17 times as much as our Sun, while its little companion weighs only about 1. That is a wildly lopsided pairing, far more unequal than the usual textbook expects, and it has opened up new questions about how such mismatched partnerships can form at all. Once again, the giant on the hunter's shoulder had taken something the experts thought they understood and quietly bent it out of shape, leaving them with fresh puzzles to chase. And there is a tender, almost mournful coda to the story of the companion, something that gives the whole pairing a quiet ache when you sit with it. The little star is too close to the giant. Their orbit is so tight that the companion actually moves within the vast, tenuous outer atmosphere of Betelgeuse itself, ploughing through the giant's extended shroud of gas as it circles. And friction, the gentle dragging resistance of moving through all that material, will slowly, over the ages, rob the little star of its energy and pull it inward. The orbit will decay. The newborn will spiral closer and closer to the giant, and in the end, in perhaps 10,000 years or so, Betelgeuse will draw its small sibling all the way in and consume it entirely. The giant will swallow the infant. Some astronomers, charmed and a little sad, have already begun calling the companion by a more dignified name than Betelgeuse. They have suggested Siwarha, drawn from old star lore, a name to carry it through its short and doomed remaining time. A newborn star, the same age as the giant beside it, fated to be gathered back into that giant before it ever fully comes alive. There is something in that worth holding gently as you drift towards sleep. Even the stars are not exempt from time. Even they are born and circle one another and are lost, and yet there is no tragedy in it. Not really. Only the slow, patient turning of things, the same turning that made the dust, that made the earth, that made you. The next good chance to look at the companion again, to confirm everything and learn more, will come in the year 2027, when Siwara once more leans out from behind the glare of the giant, and astronomers are waiting for it, the way you might wait for a familiar light to reappear at a window. The story is still being written. That is part of the wonder of it. But now we have to turn, slowly and without alarm, to the heart of the matter, to the reason this star carries the word doomed even on a calm night like this one. Because for all its beauty, for all its surprises, the one thing that has never been in doubt about Betelgeuse is how its story ends. It will explode. Not maybe, not perhaps. It will, with absolute certainty, end its life as a supernova. The only question, the question that genuinely keeps astronomers leaning forward in their chairs, is when. And to understand both the certainty of the ending and the uncertainty of its timing, we need to go down, away from the boiling red surface, away from the dust and the companion and the light, down through the vast layers of the star, all the way to its core, down to the place where the real story is being decided, in a furnace we will never see directly, far beneath the surface, where a slow and inevitable countdown has already begun. Let your awareness sink inward with me now, the way you might sink deeper into the mattress beneath you, past the cool red surface, down through layer after layer of glowing gas, each one hotter and denser than the last, the pressure building, the temperature climbing, mile after mile, for a distance so vast that the journey from the surface to the core of Betelgeuse would itself dwarf the entire span of our solar system. And finally, at the very center, we arrive at the core, a region of unimaginable heat and crushing pressure, where the true life of the star is decided. This is the engine. This is where the fusion happens that holds the whole titanic structure up against the relentless inward pull of its own gravity. Everything you have seen, the size, the glow, the convection, the slow death, all of it is governed by the quiet, ferocious work happening here. A star is, at its heart, a balance, a standoff between two opposing forces that lasts for the entire life of the star. On one side, there is gravity, pulling everything inward, always, relentlessly, trying to crush the star down into the smallest possible space. On the other side, there is the energy pouring out of the fusion in the core, pushing outward, holding the star up, keeping it inflated against gravity's pull. As long as the fusion in the core keeps producing energy, the outward push balances the inward crush, and the star holds its shape, stable, for millions or billions of years. The whole life of a star is just this balance, maintained moment by moment, the fire in the core, pushing out exactly as hard as gravity pushes in. And a star dies at the precise moment that balance finally fails. The moment the fire can no longer push back. Now here is the part that gives the ending its terrible inevitability, and it is one of the most elegant and unforgiving facts in all of nature. A star like our Sun fuses hydrogen, the lightest element, into helium, and that is essentially all it will ever do. When the Sun runs out of hydrogen, It does not have enough mass, enough gravity, enough crushing weight to push its core to the temperatures needed to fuse anything heavier. It will swell, shed its layers gently, and settle down into a quiet retirement as a slowly cooling ember. No explosion. A peaceful end. But Betelgeuse is far heavier than the Sun, 16 or more times heavier, and that enormous weight changes everything. Its gravity is so powerful that when it runs out of one fuel, the crushing collapse of its core drives the temperature high enough to ignite the next. And so, a massive star does not die when it runs out of hydrogen. It simply moves on to the next fuel. And the next, climbing a ladder of heavier and heavier elements, each rung burning hotter and faster than the one before. Walk up that ladder with me slowly, because the rhythm of it is part of the story. First, for most of its life, the star fuses hydrogen into helium, the long and stable phase, the millions of years of ordinary stellar life. When the hydrogen at the core runs low, the core contracts, heats, and begins to fuse helium into carbon and oxygen. This phase is much shorter than the first. Then, when the helium runs low, the core contracts and heats again, and begins to fuse carbon into still heavier elements, neon and magnesium and the like. This phase is shorter still. And the pattern continues, each new fuel igniting only after the last is exhausted, each phase faster than the one before, the star burning through heavier and heavier elements in an accelerating rush toward the end. Carbon burning might last only 1,000 years or so. The phases beyond it are faster yet. The star is racing now, climbing the ladder 2 rungs at a time, each step shorter, the whole structure straining as the core grows hotter and denser and more frantic by the day. And at the top of the ladder, there is iron. And iron is where the music stops. This is the crux of everything, the single fact on which the death of Betelgeuse turns, and it is worth letting it arrive gently and completely. Every step up the ladder so far has released energy. Fusing hydrogen into helium releases energy. Fusing helium into carbon releases energy. All the way up, each fusion reaction pours out energy that pushes outward and holds the star up against gravity. That is the whole point. That is what keeps the standoff going. But iron is different. Iron is the most stable element in the entire universe for this kind of nuclear bookkeeping. And because of that, fusing iron does not release energy. It absorbs it. To force iron atoms to fuse, you have to put energy in rather than getting energy out. The moment a massive star's core fills with iron, the fire goes out. Not because there is no fuel left, but because the fuel that remains, the iron, takes energy instead of giving it. The outward push collapses. The standoff that has held the star up for 10 million years ends in an instant. And gravity, which has been waiting, patient and relentless, for the entire life of the star, finally wins. What happens next happens faster than you can imagine. We are not talking about years, or days, or even hours. When the iron core of a massive star reaches its limit, and the fusion that supported it cuts out, the core collapses in on itself in about a single second. A ball of iron larger and more massive than our entire sun, crushed down by its own gravity, falls inward in the time it takes you to draw one slow breath. The center is compressed to a density so extreme that it is almost impossible to describe. The entire mass of a star's core squeezed into a sphere the size of a city, so dense that a single spoonful of it would weigh as much as a mountain. The infalling material crashes down onto this suddenly rigid core and, finding it cannot compress any further, rebounds. It bounces. A shockwave of unthinkable power tears back outward through the star, and the outer layers, all those vast regions of gas the size of solar systems, are blasted into space at speeds of tens of thousands of miles every second. The star tears itself apart. For a few weeks, the explosion blazes with the light of billions of suns, briefly outshining whole galaxies, scattering across space all the elements the star built up over its lifetime, the carbon and oxygen and silicon and iron, seeding the darkness with the raw material of future worlds. And in the center, where the iron core collapsed, there remains a small, dense, ferocious remnant. Either a neutron star, a city-sized ball of impossibly compressed matter, or, if the original star was heavy enough, something even stranger and darker, a black hole, a place where gravity has won so completely that not even light can escape. This is the fate written into Betelgeuse from the moment it was born, too large. The ladder of elements is already being climbed in that hidden core, 600 light-years away. The star is somewhere in the late, fast phases now, though exactly which rung it stands on is one of the things astronomers are still working out. And here we arrive, finally, at the question that has been waiting beneath this entire story, the question that genuinely fascinates and unsettles the people who study the sky. We know how Betelgeuse ends. We know it ends in fire and collapse, and a remnant in the dark. The only thing we do not know, the only thing we cannot pin down, is when. When will Betelgeuse explode? It is the question everyone asks, and the honest answer is a beautiful kind of uncertainty, the kind worth resting in rather than resolving. Let me lay out for you, slowly, what we actually know and what we genuinely do not, because the truth here is far more interesting than any confident headline. A few years ago, in 2023, a group of researchers studied the way Betelgeuse pulses and breathes, the rhythms of its expansion and contraction, and they built models to match those rhythms to what was happening inside, and their analysis suggested something that made the world sit up. They concluded that Betelgeuse might already be in the late stages of burning carbon in its core, well up the ladder, far closer to the end than most people had assumed. And if that were true, then on the cosmic clock, the explosion might come not in some comfortably distant future, but possibly within a span of mere decades or a few centuries. Some interpretations of that work suggested the star could have only a few hundred years of fuel left, perhaps less, with the final core collapse following not long after the carbon runs out. By the standards of the universe, that is essentially tomorrow. That study set hearts racing, because it raised the genuine possibility that we, the people alive now, might be living in the last lit years of a star that has shone for 10 million. But, and this is important, that is not the whole picture, and it is not the settled view. Other astronomers, studying the same star with different methods, have arrived at much calmer conclusions. Many models suggest Betelgeuse is in an earlier and more stable phase of its life than the carbon-burning interpretation implies, perhaps still steadily fusing helium, with not hundreds, but potentially 100,000 years or more remaining before the end. And here is where the discovery of the companion matters again, in a quiet but significant way. Remember that the long 6-year rhythm of Betelgeuse, the slow swelling and fading, was once one of the pieces of evidence people used to argue the star was deep in its final phases, behaving erratically as a dying giant might. But now we understand that this 6-year rhythm is not a death rattle at all. It is simply the gentle effect of a little companion, star brushing dust aside as it orbits. One of the supposed warning signs turned out to be nothing of the kind. It turned out to be Beetlebuddy, going about its quiet rounds, and so some of the urgency that surrounded those imminent explosion claims has eased. The picture that many astronomers now favor is of a star that is certainly near the end in cosmic terms, certainly destined to explode, but most likely not on the verge of it in any human sense. Most likely thousands, perhaps tens of thousands, of years away. Most likely something that no person now alive will witness. So which is it? Decades, or 100,000 years? And the truthful answer, the answer that captures the real state of human knowledge, is that we do not know, and the range of genuine possibility is staggeringly wide. It could happen, in principle, within our lifetimes. It could, with much greater likelihood, not happen for longer than our entire species has so far existed. Both of those statements are honest. Both fit within the bounds of what the evidence allows. And the reason for this enormous uncertainty takes us right back to that humbling truth from earlier. The one worth resting your mind on. We have never watched a star in its final approach to a supernova. We have no proven checklist of symptoms. We are reading the last pages of a book whose ending we have only ever glimpsed in the form of distant flashes long after the fact. Betelgeuse, being so close, so large, so studiable, is our single best chance to actually learn what those final pages look like, and so the people who study it are not really frightened of it. They are leaning toward it, the way you lean toward someone about to tell you a secret. They are watching a giant approach a threshold. No human has ever watched a star approach in real time, and they cannot say whether the crossing is decades away or 1,000 centuries away, and that not knowing, that being present at the very edge of human knowledge, is the most quietly thrilling thing in their professional lives. The fear, if you can even call it fear, is really just wonder that has not yet found its footing. It is the feeling of standing close to something vast and ancient and not being able to predict it. That is the thing that keeps them up at night. Not danger, mystery. And speaking of danger, let us put that question fully to rest now, because it matters for the peacefulness of this, and because the truth is genuinely reassuring. You may have heard somewhere a vague worry that a nearby supernova could harm the Earth. And it is true that a supernova is one of the most violent events in the universe, flooding its surroundings with radiation and high-energy particles. If a star were to explode very close to us, within a certain distance, it could, in principle, damage the thin layer of our atmosphere that protects us. But the key word is close. Astronomers have studied this carefully, and the rough threshold of concern, the distance within which a supernova might begin to affect life on Earth, is something like 160 light-years. And Betelgeuse is not 160 light-years away. Betelgeuse is roughly 600 light-years away, perhaps more. It is something like 4 times farther than the distance at which it would need to be to pose any threat at all. When Betelgeuse explodes, whether that is in 50 years or 50,000, it will be, for the Earth, completely and entirely harmless. Not a little harmful, not slightly risky, harmless. The explosion that ends this giant's life will not so much as ruffle a single leaf on a single tree on our planet. You are safe. You have always been safe. The story of Betelgeuse is not, and never was, a story about something coming for us. Let that settle in fully. There is nothing here to fear for yourself, or for anyone, or for the world. Whatever happens to that distant red star, it happens far away, across an ocean of space so wide that its violence will reach us only as beauty. And oh, what beauty it will be. Let yourself imagine it now, gently, as something to look forward to, rather than to dread. even if neither you nor I will likely be the ones to see it. When Betelgeuse finally does explode, the light of that explosion will cross the 600 light-years to Earth, and one night, or perhaps one day, the hunter's shoulder will begin to brighten. And it will not stop at the brightness of a bright star. It will keep climbing, growing more brilliant night by night, until it outshines every other star in the entire sky by a wide margin. At its peak, the supernova may shine with a brightness rivaling that of a substantial fraction of the full moon, concentrated into a single dazzling point. It would be far brighter than the planet Venus, which is itself the brightest thing in our night sky after the moon. It would be bright enough to see in broad daylight, a star visible against the blue of the afternoon sky, hanging there impossibly, a second small sun in the heavens. At night it would be bright enough to cast shadows on the ground, your own shadow thrown by the light of a dying star 600 years gone. It would shine like that for weeks, slowly fading, lingering in the sky for months, a brilliant beacon marking the death of a giant, before finally dimming away and leaving the hunter's shoulder forever dark, the familiar shape of Orion permanently changed, missing the warm red light that human beings have looked up at for all of recorded history. People all over the world would step outside to look. Children would be carried out into the dark to see it, and they would remember it for the rest of their lives and tell their own grandchildren, just as people once told stories of the great new stars that blazed up in centuries past. Because this has happened before, in human history, though never so close and never so bright. The last time a star exploded close enough in our own galaxy to be plainly seen with the naked eye was more than 400 years ago, in the early 1600s, before the telescope had even been turned fully to the heavens. Generations of astronomers since then have lived and worked and died without ever once seeing a supernova in our own galaxy with their own eyes. It is one of the great longed-for events of astronomy, a galactic supernova, close and bright and studiable, and Betelgeuse is the most likely candidate to provide it, the nearest giant standing closest to the edge. When it comes, whenever it comes, it will be witnessed and measured and treasured by whoever is alive to see it. And they will learn, in those weeks of brilliant light and the long study of the glowing remnant that follows, the answers to questions we cannot answer tonight. They will finally read the last pages of the book. And here is a quiet marvel of human ingenuity, a thing we have built that lets us listen for that ending in a way our ancestors never could. When a massive star's core finally collapses, the very first thing it sends out is not light. It is something far stranger and far faster to escape. In the instant of collapse, the dying core releases an almost incomprehensible flood of tiny ghostly particles called neutrinos. Neutrinos are among the most elusive things in all of nature. They are so reluctant to interact with ordinary matter that they pass straight through it as though it were not there at all. Right now, as you lie here resting, trillions of neutrinos from our own sun are passing through your body every single second, harmlessly, without you feeling a thing, without touching anything, slipping through you and through the earth itself, and out the other side, as if the whole planet were made of empty space. And because neutrinos pass through matter so freely, when a star's core collapses, they escape the dying star almost instantly, streaming out at very nearly the speed of light, while the light of the actual explosion, the visible flash, has to claw and fight its way out through all the vast collapsing layers of the star, a journey that takes hours longer. Which means the neutrinos arrive first. The neutrinos are the whisper that comes before the shout. We know this is true because it has happened, once, within living memory, and we caught it. In the year 1987, a star exploded in a small companion galaxy near our own, a place called the Large Magellanic Cloud, far more distant than Betelgeuse, but still close enough in cosmic terms to study. And in the hours before, the light of that explosion reached our telescopes, deep underground, in great tanks of pure water, built to catch exactly these ghostly particles. Detectors registered a tiny handful of neutrinos arriving from the direction of that dying star. Only a couple of dozen of them, out of the unfathomable flood that swept through the Earth in those seconds. But it was enough. It was the first time human beings had ever detected neutrinos from a supernova, the first time we had directly sensed the collapse of a stellar core, and it confirmed, beautifully, everything the theories had predicted about how massive stars die. We had reached out and felt the death of a star with an instrument of our own making, hours before we could even see it. And so, knowing this, astronomers have built something rather wonderful. They have linked together the great neutrino detectors of the world, the enormous underground tanks scattered across different countries, into a kind of shared listening network, a tripwire stretched across the sky. If a star in our own galaxy were to collapse, if Betelgeuse itself were to finally reach the end, the burst of neutrinos would wash over the Earth and trip those detectors all at once, and an automatic alert would go out, a quiet electronic message flashing to observatories around the world, saying, in effect, "Look now, point your telescopes, something has just died and the light is coming." We would have hours of warning, hours to aim every instrument we have at the hunter's shoulder and watch, in real time, with everything we possess, as the light of the supernova finally arrived and the star bloomed into brilliance. After all of human history, spent gazing at that red star and wondering, we have built ourselves a way to be ready, to be watching, to not miss the moment when it comes. There is something tender in that, the way we have prepared, patiently, for an event that may not happen for 100,000 years, simply because we do not want to look away at the wrong moment. This would not be the first time human beings witnessed such a thing, though it has been a very long time. Scattered through the old records of the world, there are accounts of new stars that suddenly appeared in the sky, blazed for a while, and faded. In the year 1054, watchers in China and across the world recorded a brilliant new star that flared up so brightly it could be seen in broad daylight for weeks, and then slowly dimmed over the following months until it vanished from view. We know now what they saw. They saw a supernova, a massive star ending its life, and the glowing wreckage of that very explosion still hangs in our sky today. A tattered, beautiful cloud of expanding debris that we call the Crab Nebula, the scattered ash of a star that died nearly 1,000 years ago, lit up by what remains at its heart. Later, in 1572, and again in 1604, 2 more brilliant new stars appeared and were carefully studied by the astronomers of those days, men who watched them night after night and recorded their slow fading, and who began, in watching them, to understand that the heavens were not the changeless, perfect, eternal realm that people had long believed. The stars, it turned out, could be born and could die. And since that last one, in 1604, more than 4 centuries have passed without a single supernova close enough in our own galaxy to be plainly seen with the naked eye. Generation after generation of skywatchers has waited. The telescope was invented. Whole sciences were born and grew up. And still no nearby star has died for us to see. We are overdue, in a sense, for the sky to show us one again. And Betelgeuse, the great red giant on the hunter's shoulder, standing closest to the edge of all the stars we can easily see, is the one most people are quietly hoping will be the next. And there is one more thread to gather up before we let this rest, the one we left hanging at the very beginning, the one about the age of the light. Remember that the glow reaching your eye tonight left Betelgeuse roughly 600 years ago, which means that we do not see Betelgeuse as it is. We see Betelgeuse as it was 6 centuries past. And this leads to a thought that people love to raise, often with a little shiver. What if Betelgeuse has already exploded? What if, sometime in the last 600 years, that giant reached the end of its ladder, and its core collapsed, and it blazed up into a supernova, and the light of that explosion is even now racing toward us across the dark, not yet arrived, so that the calm red star you see tonight is in truth already gone, already a memory, already an expanding cloud of glowing debris. And we simply do not know it yet, because the news has not had time to reach us. It is a haunting idea. It makes the skin prickle. But hold it gently, because the truth is calmer than the shiver suggests. Yes, it is technically possible that Betelgeuse has already exploded, and we are simply waiting for the light. But think about the numbers we just walked through. The window in which Betelgeuse might explode is, by even the most aggressive estimates, decades to centuries, and by the more favored estimates, tens of thousands of years wide. 600 years, the travel time of the light, is a tiny sliver of that vast window. For the star to have already exploded, and for that light to be arriving in just the right narrow band of years for us to be the generation that finds out, the timing would have to be an extraordinary coincidence. It is far, far more likely that Betelgeuse is exactly what it appears to be tonight. A living giant, still shining, still boiling, still shedding its dust and circling its little companion, with its end still ahead of it rather than behind. The red light on the hunter's shoulder is, almost certainly, the light of a star that is still there. Old news, yes, 600 years old. But the news of something still alive. And even if the unthinkable coincidence had occurred, even if the light were already on its way, there would be nothing to fear in it, and nothing to mourn. It would only mean that one night you, or someone after you, would step outside and find the sky a little brighter, and would understand that a giant had completed the journey it was always going to complete, had scattered its substance back into the dark to seed the worlds and the stars and perhaps the living things of some unimaginably distant future. The same way the dust of giants long dead, gathered over billions of years, came together to form the ground beneath you, and the iron in your blood and the calcium in your bones and the very atoms that are, right now, doing the gentle work of carrying you towards sleep. You are made of the endings of stars. So is everything you have ever loved. The death of Betelgeuse, whenever it comes, is not an ending so much as a return, a giving back, a scattering of seeds. There is nothing in it to fear. There never was. So let it go now. Let the question of when drift away unanswered, because it does not need answering tonight, and because the not knowing is its own kind of peace. Picture the star one last time, soft and orange on the shoulder of the hunter, the way it has hung in the winter sky over every person who has ever lived, over the first people who traced the hunter's shape in the dark, over the sailors who steered by it, over the children carried outside to see it, over you, tonight, wherever you are resting. Picture its slow, boiling surface, the great bubbles of plasma rising and sinking. patient and unhurried. Picture the little companion, the same age, still a newborn, drifting around it in the dark, with thousands of years yet before the giant gathers it home. Picture the dust streaming gently away into space, cooling, hardening, the seeds of worlds not yet born. Picture the deep, hidden core, climbing its ladder of elements so slowly that the climb may not finish for longer than our species has existed. There is no rush. There is no danger. There is only a giant, far away, taking its long, slow time, as it always has, as it always will, until the moment it does not. You do not have to hold any of it anymore. You do not have to remember the numbers, or the names, or the order of the elements on the ladder. You do not have to wonder when, or worry about whether, or carry any of it into your sleep. Let the facts soften and blur, the way the lights of a distant town soften and blur as you drift past them late at night. Let the red star become just a warm color behind your eyes. Let the vast distances become just a feeling of space and quiet opening out all around you. Let the slow boiling surface become the slow rhythm of your own breathing, in and out, unhurried, like the breathing of a giant that has all the time in the world. The hunter will keep his watch over the winter sky. The red star will keep shining, its old light crossing the dark to reach us, as it has for all these centuries, faithful and warm and in no hurry at all. And you, resting here, made of the dust of stars that ended long ago, gathered up across billions of years into this one quiet, breathing life, you can let yourself rest now, completely. There is nothing to solve. There is nowhere to be. There is only the slow turning of enormous and beautiful things, far away, carrying on without you, asking nothing of you, while you let go, and grow heavy, and drift, down and down, into the soft dark, into sleep.